This video lecture is focused on the current and more sustainable fuels for seagoing ships. I will discuss the different fuel types and the organizations that influence these fuel types and quality by their regulations. There are two main marine fossil fuel types. First of all, the distillate marine fuels with the clear appearance and low viscosity, much like diesel fuel for cars and trucks. Besides distillate marine fuels, there are also the much heavier residual marine fuels with the high viscosity and black appearance. Residual marine fuel is commonly referred to as heavy fuel oil, HFO, while distillate marine fuels are commonly called marine gas oils, or MGOs. Both these common fossil fuel types are combusted in diesel-type engines. In contrast to hydrogen and methanol, electric spark plugs are not needed for ignition. Heavy fuel oil is often combusted in lower and medium-speed diesel-type engines, as the lower rotation speed provides for longer combustion residence times. This ensures good evaporation and complete combustion of the heavy fuel oil droplets, leading to fewer exhaust fumes. A heavy fuel oil system is commonly equipped with centrifuges and fuel tank heating to achieve lower viscosity and, as such, small droplets at the injectors. HFO also needs to be heated in order to be able to be pumped or bunkered into the fuel tanks. Besides hydrocarbons, HFO also contains other components such as nitrogen, sulfur and phosphorus. This can lead to harmful emissions of NOx, sulfur dioxide and soot. To reduce the emission of sulfur dioxide, the International Maritime Organization IMO and its member countries have agreed to stepwise decrease the maximum allowed sulfur content in marine fuels. This is shown in the graph. For specific emission control areas such as the European North Sea, stricter sulfur norms apply. For NOx, regulation is on its way. Besides the marine fuels based on fossil oil, there are currently two main types of biodiesel fuels used in the transport sector. Both of these can also be applied in marine ship engines. First of all, there is the fatty acid methyl ester, or FAME, which is produced from, for instance, frying oil. This FAME is also used to produce biodiesel for cars. A disadvantage of FAME biodiesel is that it may solidify during winter conditions. The other biodiesel type is the hydrogenated vegetable oil, made with hydrogen. This biodiesel is often called HVO. The composition is very similar to common diesel fuel and as such can easily be blended with diesel fuels. Currently, the production of FAME and HVO is more expensive than the production of HVO and MGO. Within the Netherlands, large quantities of FAME biodiesel recently have been blended with marine fuels and successfully used in ship engines. The blending of up to 48% of FAME biodiesel with HVO results in stable mixtures, even though there are huge viscosity and density differences. EU regulations like the Renewable Energy Directives, promoting the application of sustainable fuels in cars and trucks, were also used to successfully blend marine fuels with biodiesel in the Netherlands. With regards to alternative marine fuels, there seems to be no clear single pathway towards more sustainable marine transport. Current options are biodiesel, LNG, hydrogen, methanol, and hybrid diesel-electric systems. Aspects that need to be considered when deciding on the most favorable options are the possible CO2 reduction, fuel availability, fuel tank size, and whether the biofuel can be used in current ships or not. It is expected that until 2030, especially biodiesel, LNG, and hybrid diesel-electric systems will be further implemented. Pressurized hydrogen currently has the disadvantage of extremely large fuel tank sizes. Both the EU and also the IMO are developing new mandatory regulations for more sustainable marine transport in 2030. With regards to CO2 emissions, the EU Parliament already decided that shipping should become part of the EU trading system. The larger EU ships are already obliged to monitor and verify CO2 emissions of each ship. The IMO has also implemented new regulations for both new and existing ships. For instance, all new ships have to become 30% more energy efficient than those built in 2014. Also, existing ships have to have energy efficiency management plans in place, looking at things like improved logistics. For energy efficiency, the focus is not only on different fuels but also on other measures. For instance, adding vertical rigid sails to cargo ships, saving up to 10% of diesel, or using the ships at lower speeds. This is called Ecoshipping. So to conclude, marine shipping is becoming more sustainable by switching to more sustainable transport fuels. Up to now, there is no clear single pathway towards sustainability. However, we think that the marine shipping sector will be able to further adopt successful technologies, like for instance biodiesel and hybrid diesel-electric from the land transportation sector.